Here's yet another rule of logarithms that turns out to be very powerful. It gets used a lot. It's based on this rule of exponents. If we have a to the b and we take that expression and raise the whole thing to the c power, we get the same thing as a to the b times c. That is, in this case, we multiply the exponents. Check that out in a simple example if you're unfamiliar with it. It's related to this rule of logarithms, as it turns out. Log base 10 of x to the y is equal to y log base 10 of x. That is, we can take this y that's in the exponent, x raised to the y, and when we take the log of it, the y can be brought down out in front, so we get y times log base 10 of x. That holds for x greater than 0. Let's see how we can prove this rule using this rule. So we start with this side of the expression, log base 10 of x to the y. How are we going to end up with this? So we're going to go through a chain of equalities and hope to end up with this. And the trick is to take that x right there and use what we know about logarithms and exponentiation undo each other, and take that x and write that x as 10 times log 10 of x. So that log 10 matches this log 10, that y matches this y, and all I've done is I've taken that x and I've replaced it by 10 raised to the log 10 of x. And that expression right there is the same as x, because 10 and log 10 undo each other. And so now I have an expression that looks like this one, and I can use this rule of exponents. So this is 10 raised to the log 10 of x, all of that raised to the y. Log 10 of x can be thought of as b, y can be thought of as c, so I just multiply log 10 of x and y together. So in the next expression, that log 10 stays the same, that's still log 10. That 10 stays the same. But I'm multiplying these two exponents together. Log 10x times y, I'm going to write as y times log 10x. Now look what we have. Magic. Log base 10 of 10 to the something, that log base 10 cancels out that 10, and we're left with y times log base 10 of x. That's what we said. Log base 10 of x to the y is y times log base 10 of x. That's using this rule, we can derive this rule. Okay, let's look at an example. Suppose we want to show or estimate the size of log base 10 of 7 to the 1,000. Well, this rule makes it very simple. X is 7, y is 1,000, so log base 10 of 7 to the 1,000 is equal to 1,000 times log base 10 of 7. Since 7 is between 1 and 10, we know log base 10 of 7 is between 0 and 1, so 1,000 times log base 10 of 7 is less than 1,000 times 1. So log base 10 of 7 to the 1,000 is definitely less than 1,000. So that gives us a way of estimating what things are. That is, that exponent right there, if this is a number between 1 and 10, gives us an upper bound on how big these things are. But this rule is even more useful because we can use it to help us take derivatives and integrals. If we want to find the derivative of log base 10 of 23 to the x squared, well, that might look really hard. I mean, there's a log base 10, there's a 23. How do you take the derivative of log base 10 and 23? Well, you don't have to do any of that. You just use this rule. Whenever you see log base 10 or log base anything of something to a power, that power can come down out in front. So that is, we can say, instead of taking the derivative of this, we can take that x squared and move it down out in front and take the derivative of x squared times log base 10 of 23. That helps a lot. Going from there to there was very useful because log base 10 of 23 is just a constant. It is just a number. Don't let it scare you. All you have to do is take the derivative of x squared. You get 2x times log base 10 of 23. That's the answer. That's all you have to do. Log base 10 of 23 is just a number. Similarly, we can integrate. If we want to integrate log base 10 of 3 to the x dx, bring the x down. So instead, integrate x times log base 10 of 3 dx. That is, use this rule and bring that out of the exponent out in front. Log base 10 of 3 is again just a constant. It can sit out in front. Now we just have to integrate x dx. Integral of x dx is x squared over 2. So we get log base 10 of 3 times x squared over 2. But you have to remember to add on the plus c. This is a very powerful rule in dealing with logarithms.